Yo, what's up?
We
Are here
to
talk about
science.
science. Hello. Today we will be making a homogeneous mixture. River, add the blue stuff. This is now a homogeneous mixture. The reason it is a homogeneous mixture is because it all looks the same.
And it does not separate.
We'll now explain further.
Hello, we're back. This homogeneous mixture is very mixable because it stays mixed.
And it is very not immiscible because of what he just said.
No, we got 30 minutes. No, do one 30 minutes. Come on, Dad. Go. Yeah, 30 minutes after the talk.
This is a homogeneous solution. It is a mixture of 14 karat gold and steel. It is called an alloy because it is a solid homogeneous mixture, meaning all the parts are so well put together. And I just used it to kill Mitchell Riley. He's now dead. Rest in peace, Mitchell Riley.
Thank you. A solution. Rick Khalifa, hold this.
Thank you.
We will be taking the sea salt, which is a solute, and pouring it into this solvent. A solvent is something that dissolves a solute. We pour the sea salt in, give it a little swirl. The sea salt is gone. It has been dissolved. Magical.
And now I shall demonstrate what an insoluble object looks like when it is dropped into a solvent. We have here a balled up piece of tape demonstrating a insoluble object. I see that you are zooming in. I will now put the piece of tape in the water. As you may now see, it has not dissolved like the salt.
Yeah, it kind of just floats there.
Yes.
Okay.
Yes, it does.
So, if you have a solution like this, or any liquid or any gas, you can take it and you can look at how things normally are. Like, look at that man over there with the blue headphones. Now, just imagine this man with the blue headphones. Just imagine instead now that you're floating in this, or pretend this was turned into a gas. See, now whenever the light goes to that man over there with the blue headphones, it's gonna hit him and just bounce off normally. But with this in the air, it's gonna hit these things, and the light are gonna bounce off in different directions. So it's gonna hit this, and it's gonna this way, that way, and you're just not gonna see him as well. You're just not gonna see him as well. And this is called the Tyndall effect, when light is scattered by particles in the air.
Wow, thank you. Hello, today I'm going to be talking about crystallization. Basically what this is it's a separation technique that is used to make a solid from a solution. Alright, so how I'm going to be explaining this today is through an experiment that can be used to crystallize something to make rock candy. Wow, how delicious, right? Alright, so what we do is we take regular water and we boil it. We boil it so it's just really hot and it's easy to mix things. And you just pour regular sugar. See that? Boop, boom, right in there. Get that going, and then you mix that in. You just mix that sugar, get it all dissolved, make it so you can't see it anymore. You don't want to see that sugar. And then you want to take 2 wooden sticks, and you want to get sugar on it. And then you want to put these 2 sticks and put them in the mixed sugar water that you have. And you want it to have them sitting so they're not touching the bottom, but they're just enough in there. Alright? And you let that sit for like a couple days. And eventually it turns and crystallizes. Thank you.
We join our noble scientists to talk about distillation. Wait a minute, where are they?
Oh, we never explained
Hello.
distillation.
This water is distilled because the minerals were taken out by being heated up.
Distillation. Distillation is the process of purifying a liquid by heating or cooling it. So here's an example. We have seawater, which is very salty. Normally you wouldn't see the salt, but this is very salty stuff. First, it's heated. The heat boils this water, and the water turns to steam. The steam travels up this way and into this condenser. The condenser has cool water in it, and as it comes down, the steam eventually turns into water. This water is now pure H2O. And in the end, this beaker is filled with salt. Just pure salt.
This is the process of filtration.
This is how you separate a solid from a liquid, by using a porous material.
Oh God. Very porous.
See these? Look at that.
Wow, look at
Oh
what we
my.
caught. That's gonna help with the wall.
Today we are here to talk about suspension. Suspension is when particles float in a solute like water. So we have this flour here, some good flour, and we're going to pour this in the water. Okay. Going. Wow, would you look at that? The flour is in the water. Now we will give it a stir. Nice and milky, just how I like it. Alright, now we wait.
What first is a heterogeneous mixture? A heterogeneous mixture is a mixture that is unlike a homogeneous mixture in that the particles are going to be the particles of the solute are going to be separate from the particles of the solvent, which is to say that they're not going to mix and become a uniform togetherness. Okay.
We have waited a while, and now we begin to see a bottom that has flour. The flour has sunk to the bottom because it won't mix with the water. This up here is suspension at its finest. The flour particles are suspended, and when the time is right, they will drop all the way to the bottom down here.
Okay. Then you have colloids. Okay. And colloids are going to go a little bit different. And the way you're going to have colloids is that the solute is going to be, the solute's going to be all over in little particles. It's not going to settle out in the solvent. And so this solution is going to be, or this mixture, I should say, it's going to be much more, kind of spread apart. And so that's the primary difference.
Hello, sir. How you doing today?
I'm doing quite well. Good to see you.
What's going on back there?
We'll see over here we have the CATs. The CATs are working in the construction of the wall.